channel. So in the previous sessions we have discussed about the quantitative aptitude. So two problems I have discussed regarding this calendar problem and finding the digit at a unit's position, right? So in today's session we will go with another concept of quantitative aptitude, that is number system. Right. So number system in quantitative. Right, in this quantitative aptitude number system, mainly we will discuss about the divisibility tricks. Right. So So what is this divisibility tricks? So we may get the question as the large number will be given and we are supposed to find whether that particular large number is divisible by given number or not. So there will be given one more number. So we have to find whether the large number is divisible by that given number. For example, consider some 1, 2, 3, 4, 5, 6, 7, 8. So this is a large number. This is not a number, this is a large number, and we have to find whether this number is divisible by some 5 or 6. Okay, whether we have to find whether the given number is divisible by 6 or not. Okay, such type of questions we may get. So for that we can have small tricks so that we can easily find out. Okay, so I will tell you the tricks and then we will find two examples and we will close. So to check the divisibility of 2, divisibility of 2, so 0, 2, 4, 6 and 8 should be at units position. 0, 2, 4, 6, 8 should be in the units position. Then automatically the given number is divisible by 2. Next, the divisibility of 3. So what is the shortcut for finding this divisibility of 3? If the sum of digits of a given number is divisible by 3, then automatically we can say the number is divisible by 3. Okay, sum of given digits is divisible by 3, automatically we can say that the number is divisible by 3. See, for example, you take this, for example, if you consider some 1, 2, 3, 4, whether the number is divisible by 2 or not. So we can find the units position which is one among these 5 numbers, right? So then automatically we can say this is divisible, right? And if you are having an example 1, 2, 3, 3, then the units position we are having the number 3 which is not one among these numbers. So it is not divisible. Right? So in such a way we can find this. So for example this one, so if you find 1, 2, 3, 4, so find the sum of digits. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So 10 divided by 3. So 10 cannot be divided by 3, the remainder will be 1. So obviously it is not divisible by 3. For example, one more example, 1, 2, 3, 3. Consider the same thing. So now sum of digits, 1 plus 2, 3, 3 plus 3, 6, 6 plus 3, 9. So 9 divided by 3, which results 3 and the remainder is 0. Right? So here the remainder will be 1, here the remainder will be 0. So that means this is divisible by 3. Hope you understood, right? So this is divisible by 3. So only one trick for finding the divisibility of 3 is, so we have to find out the sum of digits, and if this sum of digits is divisible by 3, automatically the given number is divisible by 3. Next, divisibility of 4. Now we have to find whether the given number is divisible by 4 or not. So for that, so just take last 2 digits, and if these last 2 digits are divisible by 4, that implies the given number is divisible by 4. For example, let us take 2, 3, 5, 2. Okay, so the last two digits, what are the last two digits? 52. It is divided by 4, right? It should be divided by 4. So it is nothing but 13, right? So that means remainder is 0. That means 52 is divided by 4. That means it is divisible by, the given number is divisible by 4, right? Let us take, see, I will check. So 4, so 4 5s are 20, 35, so 8s are 32, right? 32, the remainder is 3, again 32, 8. So this is the result. Okay, so you can cross check. Right. If you consider this one 1, 2, 3, and 4, and consider the last two digits 34, which is divided by 4, is equal to 8s are 32 and remainder will be 2. The remainder will be 2. That means 34 is not divisible by 4. That implies this is not, this 1, 2, 3, 4 is not divisible by 4. So this thing we have to consider. Last two digits must be divisible by 4. Right. So hope you understood this one. We'll move on to the next one. So next one, divisibility of 5. So you can say that if the unit position having 0 or 5. If the unit position is having 0 or 5, then obviously that number is divisible by 5. Right? So 1, 2, 3, 4. It is not divisible. 1, 2, 3, 0. This is divisible. Right? Because the unit position is having 4 here. Okay, the unit position is having 4 here, which is not a 0 or 5. And here the unit position is 0. So that is divisible by 5. And the next one is the divisibility of 6. Divisibility of 6. So it should satisfy, divisibility of 2 and 3. The number should be divisible of 2 and 3, then automatically it will be divisible of 6. For example, let us take 1, 2 and 3, 4. 1, 2 and 3, 4. Right? So this is, for example, for having divisibility of 2, this is perfect because the unit's position is having 4, right? So it is correct. Coming to 3, the sum of digits, that means 1 plus 2 plus 3 plus 4, that means 10. So 10 divided by 3, no, it's not satisfied. So this number is not divisible by 6. Okay. Let's take this one, 1266, right? So coming to this 2, units position there is 6, which is even number. So simply we can say that that is divisible by 2, right? Coming to the 3, find out the sum. So 1 plus 2, 3, right? 3 plus 6, 9, 9 plus 6, 15. So 15 by 3, which is nothing but 5 and remainder is 0, right? So that implies it is also divided by 3. That implies this number is divisible by 6. So only trick is, so it should satisfy the divisibility of 2 and 3. It should be the divisible of 2 and 3. Then only we can say that number is divisible by 6. Consider 8. So here, last 3 digits must be divisible by 8. Last 3 digits must be divided by 8. So if last 3 digits of the given number is divisible by 8, that obviously that automatically implies the number is, the given number is divisible of 8 on. See. So if you consider 1, 2, 3, 4, so last 3 digits, that means 2, 3, 4 are divisible by 8. So 8 2s are 16, right? So 16, so 74 is there. So 74 means 8 9s are 72 and with remainder 2. With remainder 2. That implies this number is not divisible by 8 because last 3 digits 234 it's not divisible by 8. That implies, so this is not a value. So 1 2 3 2. So last 3 numbers are 232 divided by 8. 232 divided by 8. That implies, so 2s are 16. Okay, 2s are 16. So 72. So 9s are 72 and with a remainder 0. That implies 1 2 3 2 is divisible by 8. So here I am taking an example with a 4-digit number. So you can consider some n-digit number, right? So you can consider some 6-digit number or 8-digit number so that you can try manually. So consider last 3 digits and those 3 digits should be divisible by 8. Then only we can say the given number is divisible by 8. Right? Next. These are simple tricks. Maybe you know about these tricks. Okay. You can try it. So divisible by 9. Divisibility of 9. Similarly, sum of digits. Sum of digits should be divisible by 9. Sum of digits should be divisible by 9. So 1, 2, 3, 4. Let us take an example. So here the total number is 1 plus 2, 3, 3 plus 3, 6, 10. So 10 by 9, which is nothing but 1 with a remainder 1. So it is not divisible, right? So it is not divisible by 9. So if you consider 1, 2, 3, 3, then the total sum of digits is 10. The sum of digits is 9, which is divisible by 9 with a remainder 0. That implies this number is divisible by 9. Right? So you just practice with a large number, okay? No problem. Simple. The next one is divisibility of 10. So we know that divisibility of 10 means if any number the unit's position is 0, then automatically we can say the number is divisible by 10. Right? Divisibility of 11. Divisibility of 11. So divisibility of 11 means the sum of odd places minus sum of even places should be equal to 0 or multiple of 11 or divisible by 11. So anything, okay, sum of odd places minus sum of even places. So this difference should be either 0 or that number should be divisible by 11. That means it must be a multiple of 11. See 1, 2, 3, 4. So what are the odd places? 1 and 3. So 4 minus sum of even places 6, which is nothing but minus 2. So it doesn't satisfy 0. It's not divisible by 11. So this number is not a valid. Okay. Next. 1, 2, 3, 2. 1, 2, 3, 2. So sum of odd places 1 plus 3 4 minus sum of even places 2 plus 2 4, which is nothing but 0. So it satisfies. That means that number is divisible by 11. You can check here. 12, 32, 11, 1s are 11. So 13, again 1s are 11, right? 22, 2. So 112 into 11 is nothing but 1232. So you can check manually. You can check manually. So that given number is divisible by 11. So this is how we can solve the problem by using this simple tricks. Okay, if it is divisible by 2, 3, 4, 5, 6, 8, 9, 10 and 11. Right? So in the general formulas, I will tell you the general formulas. So if the series, if the given series is 1 plus 2 plus 3 plus 4 plus and so on n, you know the formula. This is nothing but sum of natural numbers, right? So that is n into n plus 1 by 2, sum of natural numbers, right? Next, if the series is like 1 plus 4 plus 9 plus and so on, right? This is nothing but squares, sum of squares of given numbers. So n square into, n into n plus 1 into 2n plus 1 by 6. So this is a formula for sum of squares of natural numbers. Similarly, 1 plus 2 cube plus 3 cube plus and so on, that is nothing but a cubes, sum of cubes. N square into n plus 1 square by 4. This is a formula for sum of cubes. Okay, this is the basic formulas which you know. So just I am revising it. Okay. Now the main question is, what is the difference between natural numbers and whole numbers? Natural numbers and whole numbers, right? A simple difference, that is 1, 2, 3 and so on n are the natural numbers. Whole numbers are 0, 1, 2 and so on n are the whole numbers. The only difference between the natural numbers and whole numbers is 0. So in the natural numbers 0 will be not considered, and the whole numbers including the 0 all the numbers will be considered. So except 0 all the natural numbers will be the whole numbers, right? So this is a simple thing you need to know. And one more thing, difference between face value and place value. So a number will be given, they were asking about what is the face value and what is the place value. For example, let us take 1, 2, 3, and also 1, 2, 3. Here face value is, that number itself is a face value. So face value of 1 will be 1, face value of 2 will be 2, face value of 3 will be 3. The number itself is a face value. Coming to the place value of 1 is a 100th position, right? Place value of 2 is a 10th position. Place value of 3 is a units position. So the position of that particular value will be the place value. 3 is in units position, 2 will be in 10th position, 1 will be in the 100th position. Right? So this is the difference between a face value and a place value. Face value is the number itself. Whatever the number we are considering, that number itself will be the face value. Right? So coming to the basic formulas, mathematical formulas, you know all those things like so a plus b whole square, a minus b whole square, a square minus b square. So a plus b whole square plus a minus b whole square, a plus b whole square minus a minus b whole square, right? So all this I think you know, right? So just I will write, so just for a reference. So it is nothing but a square plus 2ab plus b square, a square minus 2ab plus b square, a plus b into a minus b. Similarly, this is here we are using plus, so it will be 2 into a square plus b square, and here we are giving minus, so it will be 4ab, right? 4ab, right? So similarly there are a lot of formulas, so these are the mathematical formulas, so you can go through those mathematical formulas, right? So hope you understood about this divisibility tricks. So in this session we mainly concentrated on the divisibility tricks. So hope you understood the divisibility tricks. So just practice with a large number. So and you can comment if you are having any difficulty. Right. So let us wind up today. So if you are having any doubts regarding this divisibility, so feel free to post your doubts in the comment section. So that definitely I will try to clarify all your doubts. And if you really understood my session, like my session, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.